sand is retreating. Satellite images from the past 2 years show something that shouldn't be possible. Grass spreading across the Sahara Desert in places that haven't seen a blade of green in 6,000 years, not in scattered patches, and sweeping lines, following old riverbeds that dried up before the pyramids were built. Herders in Chad are finding lakes where their grandparents only ever found dust. Farmers in Niger are pulling water from wells that had been empty since before they were born. And climate scientists are asking a question that sounds almost absurd. What happens if the world's largest hot desert turns green again? Not over 1,000 years, but within 10. At first, this sounds like good news. Maybe the best news the planet has had in decades. But the Sahara has done this before, and what happened last time should make you nervous. 11,000 years ago, the Sahara wasn't a desert at all. It was a green savanna, threaded with rivers and lakes, home to hippos, crocodiles, elephants, and human communities that painted them onto cave walls that still exist today, deep in the middle of what is now empty sand. Scientists call it the African humid period. Rainfall was roughly 10 times higher than it is now. It didn't happen by accident. It happened because of a slow wobble in Earth's orbit, a 23,000-year cycle that changes how directly sunlight hits the northern hemisphere in summer. More summer sun meant a stronger monsoon. A stronger monsoon meant rain finally reached deep into what is now the emptiest place on Earth. Then, around 6,000 years ago, the wobble shifted back, and the green Sahara didn't fade away gently. Some of the strongest evidence available suggests it collapsed in roughly a century, 1 or 2 long human lifetimes. Lakes that had existed for 5,000 years dried up while the people living beside them were still alive to watch it happen. The paintings survived. The world they depicted didn't. So here's the first reframe. Greening isn't the safe, slow, feel-good process most people imagine. It's a switch, and switches can flip in both directions, fast. Now imagine that switch starting to flip back toward green. This time, not from a wobble in Earth's orbit, but from a mix of shifting monsoon patterns, warming oceans, and decades of tree planting and land restoration projects along the desert's southern edge, the Sahel. Stage 1. The rain belt pushes north. Grass takes root in the Sahel first, then creeps deeper into the desert itself. Old lake basins begin to fill for the first time in millennia. Stage 2. For the roughly 100 million people living along the Sahara's edge, this looks like a miracle. Wells that had been dry for a generation start producing water again. Farmland expands, migration pressure eases, because people no longer need to flee land that can't feed them. Stage 3. Satellites start picking up something else entirely, something almost nobody outside a small circle of atmospheric scientists is watching. The dust plume drifting off the Sahara, visible from space for decades, is measurably thinning. At first this seems harmless. Less dust sounds like cleaner air, better visibility, one less thing to worry about. Except there's one problem almost nobody is thinking about, because it isn't happening in Africa at all. It's happening on the other side of an ocean. Every year, close to 28 million tons of dust lift off the Sahara and drift 3,000 miles across the Atlantic. A huge share of it comes from a single dried-up lake bed in Chad called the Baudelaire Depression, an ancient graveyard of microorganisms packed with phosphorus. That dust doesn't just disappear into the ocean, it falls, quietly, onto the Amazon rainforest. And it carries with it around 22,000 tons of phosphorus every single year, almost exactly enough to replace the phosphorus the Amazon's heavy rainfall washes out of its soil, year after year, like clockwork. The Amazon isn't self-sufficient. It has been borrowing fertility from a desert on another continent for thousands of years, and until very recently, nobody even knew the two were connected. So picture what happens as the Sahara turns green. Grass and roots hold the soil down. Bare, loose dust, the kind that gets lifted by wind, starts to disappear under vegetation. The dust plume crossing the Atlantic thins further, year after year. And thousands of miles away, in a rainforest nobody thought was connected to a desert at all, the soil slowly starts running short on the one nutrient it cannot produce for itself. This is the twist that scientists studying this scenario keep coming back to. Saving one of Earth's most damaged ecosystems could, indirectly, start starving one of its healthiest. And the Amazon isn't just another forest. It stores more carbon than almost any ecosystem on the planet, and it produces roughly a fifth of the world's fresh river water output into the ocean. A slow decline in its productivity wouldn't stay local. It would ripple into global carbon cycles and rainfall patterns far beyond South America. Think about what this actually means for the people living it. A farmer in Chad, watching millet grow on land his father told him was cursed, has no idea that his good fortune is connected to a fisherman 4,000 miles away in Brazil, watching fish populations quietly decline as the river system beneath him loses productivity it depended on for thousands of years. Neither of them did anything wrong. Neither of them can see the thread connecting their two lives. That's what makes this different from a normal environmental disaster. There's no villain, no single decision to point to. Just two ecosystems, tied together by wind, discovering that one's healing is the other's quiet emergency. Some researchers now argue this puts anyone managing Sahel land restoration projects in a position nobody signed up for. Every tree planted to hold back the desert, every dam built to fill a lake, is also, quietly, indirectly, a decision about how much phosphorus reaches a rainforest an ocean away. Nobody drew that dotted line on purpose. It was there the whole time, waiting to be noticed. And here's where it gets even stranger, because a greener Sahara doesn't just change dust, it changes the desert's color. Bare sand reflects an enormous amount of sunlight back into space. Vegetation absorbs it instead. That absorbed heat can intensify the very monsoon patterns driving the greening in the first place, a feedback loop that either stabilizes into a genuinely new climate, or overshoots and eventually snaps back, the same way it appears to have snapped back 6,000 years ago. Nobody currently knows which outcome we're heading toward. A Sahara that stays green for centuries, feeding its neighbors and starving the Amazon slowly over generations, or one recreating that ancient 100-year collapse, only this time on a planet already destabilized by a warming climate, with two ecosystems now silently entangled instead of one. So the desert isn't just deciding its own future anymore. It's holding a rope tied around the waist of the Amazon, 3,000 miles away, and neither one knows exactly which direction the other is about to pull first. The sand isn't gone, it just found somewhere else in the world to matter.